Presently, our night sky is going through a transformation that will leave it unrecognizable surprisingly fast, if not years. Cosmologists overall have raised the alert. Specialists like Neil deGrasse Tyson have recently affirmed that Polaris is going to detonate, and the story behind it is nerve-wracking. Its focal presence in the night sky defines its extraordinary situation as the North Star. Until now, Polaris was the one constant astronomers, pilots, and space experts could always depend on. This might change before long, and with it, our night sky and cosmic estimations might in all likelihood never be the same again. Join us as we disclose the gravity of this danger and what it means to all of us. Let's investigate the story of Polaris as it approaches its end. Polaris has for quite some time been viewed as the guiding North Star and has held a venerated place as a guiding signal for astronomers and guides for centuries. Its enduring presence in the night sky has been a foundation of navigation using the night sky, but this may all change in the blink of an eye. A new research paper, presented by the respected Royal Astronomical Society in September 2023, has cast a shaded area of uncertainty over the destiny of this divine light. The star is nearly detonating and forever vanishing from the night sky. Before we jump into the implications of this discovery, let's investigate the star in question. Polaris, also known as the North Star or Pole Star, holds a special spot overhead due to its vicinity to the heavenly North Pole. It sits straight above the Earth's North Pole, causing it to appear almost fixed in the northern sky. It's situated in the constellation Ursa Minor, also known as the Little Dipper or the Little Bear. Polaris is a fairly bright star, and in terms of size, it's a yellow-white supergiant star, considerably larger and brighter than our Sun. With a radius estimated to be multiple times that of the Sun, Polaris is often seen as a singular star, but it is quite a complex triple star system. The primary stars are Polaris AA and Polaris AB, appearing as a single star to the unaided eye, with a third companion, Polaris B, orbiting the binary pair. The interactions among these stars make a gravitational pull shaping their orbits and influencing the behaviors of each. Such complex interactions also affect the brightness and characteristics of the stars in question. Any disturbances in these interactions can lead to irregular variations in the star's radiance or throbbing patterns. However, the specific mechanisms and complexities of these interactions are not yet understood. What we do know is that since Polaris is situated around 323 light-years away, the light from Polaris requires approximately 323 years to reach Earth. This means that the light we currently see from Polaris is as it was quite a long time ago. Given the occurrence, if Polaris were to detonate today, we wouldn't be familiar with it until 323 years from now when we saw the event from Earth. It would have happened more than 3 centuries in the past. Of course, the predictions made by scientists depend on the experimental evidence we see right now, which means that Polaris might have proactively detonated, and we simply haven't seen the light from that event yet. Generally, the North Star's significance extends across different civilizations and periods, imparting significant cultural, navigational, and symbolic value. Its stability and fixed position near the heavenly North Pole have made it an invaluable navigational aid for ancient sailors and explorers. It served as a guiding beacon, allowing sailors to orient themselves and navigate across seas and lands. Since its position nearly lined up with the Earth's axis, this made it a reliable reference point for determining direction, especially in the Northern Hemisphere. Across cultures, Polaris holds symbolic significance. In certain societies, it represented stability and firmness. It is also considered a pole star that has remained fixed amidst the celestial dance of the night sky. In myths and fables, it often symbolized guidance, stability, or a heavenly anchor. Polaris' fixed position in the night sky also made it essential for astronomers. It served as a reference for observing other celestial bodies, helping with the exploration of the night sky's movements and patterns. As a variable star, Polaris shows seasonal variations in brightness, and this, in turn, helped us uncover significant discoveries about celestial properties and the nature of variable stars. This characteristic also made it pivotal in determining astronomical distances and calibrating instruments. These throbs show a predictable pattern. Essentially, that's how the star acts normally, allowing us to predict the pattern easily. However, in recent times, the star has strayed from this normal behavior. This disturbing anomaly in its throbbing cycle has surprised astronomers, prompting a closer examination of this divine anomaly. Instead of following a predictable throbbing pattern, Polaris has begun displaying an irregular and unpredictable pattern of darkening and lighting up. Scientists have now begun raising alarms over the issue, stating that the star may be nearing the end. This is consistent with a pattern of behaviors seen when a star approaches the end of its life. The dynamic expansion of Polaris' throbbing period, which was traditionally steady in its cyclic darkening and lighting up, can be attributed to the interactions between the star system that we see as one. On our end, we can see that the yearly increase in the throbbing length remains at 4.5 seconds. This may not seem like much, but it's no joking matter. Some cosmologists have marketed slow deductions, stating perhaps the gravitational interchange between the Polaris stars might have initiated these fluctuations in Polaris environmental conditions, directly affecting its throbbing patterns. However, others are not convinced. They believe that the star will explode in the near future, and there is justification for thinking as such. Since Polaris' mysterious behavior bears striking similarities to other stars like Betelgeuse, like Polaris, Betelgeuse, a prominent star in the Orion constellation, has displayed confusing abnormalities in its radiance, leading to speculation about a potential impending blast. A large number of specialists have proactively raised alarm about the star's inevitable end. The changes observed in the two stars' brightness and patterns reflect each other, drawing interesting parallels between their behaviors. Seed stars in their dusk. Stages exhibit such patterns in behavior before coming to the end. Seed stars embark on a grand journey through various stages in their evolutionary cycle. Baby stars have generally low temperatures and brightness. Following this, they progress into the main sequence stage, marked by nuclear fusion, where they remain stable for billions of years. Eventually, as their hydrogen fuel drains, they travel into the red giant stage, characterized by a rapid increase in temperature and brightness. The red giant stage witnesses a dramatic surge in energy output before culminating in a spectacular explosion, shedding their outer layers in a stunning display known as a supernova. Post-explosion, what remains is a compact, dense core known as a white dwarf. Due to captivates or normal throbs, scientists have predicted that the star has entered the stages of helium exhaustion that are seen in seed stars approaching the end of their life cycles. As a seed star depletes its steady helium supply, the star goes through sporadic throbs, causing variances in its brilliance. This exhaustion sets off a progression of events leading to sporadic light emanations, possibly mirroring the exhaustion process happening inside Polaris. It means quite a bit to note that while these anomalies align with behaviors indicative of seed stars in their twilight stages, conclusive signs of Polaris approaching the extreme phase of its life cycle remain uncertain. Stargazers continue to dissect and interpret these anomalies in pursuit of figuring out Polaris' looming destiny. If Polaris were to go cosmic explosion, it would logically be a stupendous occasion in our sky. The star would abruptly turn into a brilliantly bright object, possibly dominating the moon and becoming one of the most splendid objects in the night sky. This could last for days, weeks, or months. The star's appearance could change radically. It could change into a brilliant blaze of light or a transient object, perhaps creating vivid shades prior to disappearing. The visual display could briefly alter our perception of the natural pattern of the Big Dipper or Ursa Major, as Polaris is the current North Star and a piece of these star groupings. Rest assured that we'd be completely safe. Considering the mass and distance of Polaris, the Earth would probably be safe even if the star were to explode. Outwardly, while a Polaris blast may not be as striking as insect juices, it may still be visible to the naked eye for a long time and dominate nearby stars. Cosmologists and observatories would certainly pay heed, and the academic community and stargazers overall would be fascinated by the peculiarity. In any case, the specific visibility and impact on the planet's climate or environment would be less significant compared to a closer cosmic explosion event. But what about the star itself? Upon the incline of a potential cosmic explosion event, what will be the post-disastrous destiny of Polaris? Let's get one thing straight here. While giant stars typically end their lives with a cosmic explosion, this will probably not be the case with Polaris. Typically, when a huge star goes cosmic explosion, an epic blast occurs inside it. This event marks the last destructive stage in the life of that star, resulting in the scattering of heavy elements and sometimes leading to the formation of neutron stars or black holes. This process involves a complete breakdown of the star's core, followed by a massive explosion of energy. However, if Polaris were to follow this course, its relatively smaller mass could impact its transformation differently. Given its magnitude and innate properties, Polaris could experience a less dramatic end, evolving into a dense, compact remnant known as a white dwarf. A white dwarf is the leftover core of a star that has shed its outer layers and ceased nuclear fusion. It represents the final evolutionary stage for stars that aren't large enough to go through a cosmic explosion blast. The transformation of Polaris into a white dwarf would signify the conclusion of a life cycle, leaving behind a dense, faint leftover gradually cooling over billions of years. The exact outcome depends on the star's mass and internal composition, guiding its ultimate transformation from a supergiant to a white dwarf. In either case, its absence would mean a significant loss for stargazers and observers, compelling a redefinition of how we might interpret the night sky and celestial navigation. Astronomers would need to find an alternative reference star for navigation and recalibrate their understanding of astronomical distances, measurements, and the celestial coordinate system. In the end, the celestial story of Polaris serves as a piercing reminder of the ever-changing nature of the universe. As we anticipate the star's last journey, established researchers remain vigilant, preparing to observe and document the potential celestial spectacle that could unfold overhead if and when the time comes. It will be a heavenly event to witness as we bid farewell to a guiding beacon that has illuminated our nights for ages. At this very moment, the night sky is undergoing a transformation that could render it unrecognizable within decades or even years. Astronomers across the globe are sounding the alarm. Eminent experts, including Neil deGrasse Tyson, have affirmed that Polaris, our beloved North Star, is on the verge of exploding. The implications of this event are significant. Polaris has been a constant presence in the night sky, a guiding light for astronomers, pilots, and navigators alike. But this may soon change in a blink of an eye. A recent paper by the Royal Astronomical Society presented in September 2023 cast a shade of uncertainty over the fate of this iconic star. Polaris is on the brink of a cosmic explosion, an event that would forever change our night sky. To understand the implications, let's delve into the star in question. Polaris, also known as the North Star, holds a unique position near the celestial North Pole, appearing almost fixed in the northern sky. It resides in the constellation Ursa Minor or the Little Dipper. Polaris is a yellow-white supergiant star, significantly larger and brighter than our Sun, with an estimated radius multiple times that of the Sun. Though it appears as a single point of light to the naked eye, Polaris is actually a complex triple star system consisting of the primary stars Polaris AA and Polaris Ib, and a third companion Polaris B. The gravitational interactions among these stars influence their orbits and characteristics, sometimes causing variations in their luminosity. Polaris is located around 323 light-years from Earth, meaning the light we see today left the star a long time ago. If Polaris were to explode today, we wouldn't witness it until T34706. Navigation and holding significant social and symbolic value, its unique position near the celestial North Pole made it a crucial guide for ancient sailors and travelers, offering a reliable means of determining direction in the Northern Hemisphere. Across cultures, Polaris symbolized constancy and guidance, serving as a celestial anchor in myths and folklore. For astronomers, Polaris' significance extends beyond navigation. As a variable star, it displays periodic variations in brightness that have been crucial for studying celestial properties and calibrating astronomical distances. These predictable pulses have recently become erratic, unsettling researchers and prompting closer scrutiny. The star's deviation from its usual pulse pattern suggests it may be nearing the end of its life. The potential explosion of Polaris is consistent with the behavior observed in other stars nearing cosmic explosion. Such an event wouldn't just change our night sky but also redefine how we might interpret celestial evolution and astronomical distances. The disappearance of Polaris would mark the end of a significant era for both navigation and astronomy, reshaping the way we perceive the sky. As we await further developments, the academic community continues to monitor Polaris closely, striving to understand the complexities of this celestial anomaly and its extensive implications. As we delve deeper into the celestial narrative surrounding Polaris, we begin to unravel a tapestry woven with the threads of cosmic wonder and existential inquiry. Polaris, also known colloquially as the North Star, stands as a beacon of light against the backdrop of the night sky, its steady presence guiding the wayward traveler and the curious astronomer alike. Yet, behind this facade of celestial constancy lies a tale of cosmic evolution and imminent transformation, one that has captivated the attention of stargazers and scientists for generations. At the heart of this tale lies the enigmatic nature of Polaris itself, a star of remarkable luminosity and profound significance. Located within the constellation Ursa Minor, or the Little Dipper, Polaris occupies a position of celestial prominence, situated in close proximity to the celestial North Pole. This strategic placement has earned Polaris the distinction of serving as a celestial navigational marker, aiding mariners, explorers, and astronomers in their quest for orientation and understanding amidst the vast expanse of the night sky. But Polaris is more than just a navigational guide. It is a stellar entity of immense magnitude and complexity. Comprising a triple star system, Polaris consists of the primary stars Polaris AA and Polaris UB, accompanied by a third companion known as Polaris B. Together, these celestial luminaries engage in a delicate cosmic dance, their gravitational interactions shaping the trajectories of their orbits and influencing the luminous emanations that characterize their celestial presence. For centuries, Polaris has served as a steadfast reference point for astronomers, its unerring position in the northern firmament providing a stable frame of reference for the observation and measurement of celestial phenomena. From the ancient seafarers who charted their course by its guiding light to the modern astronomers who probe the depths of space with the aid of advanced telescopic instrumentation, Polaris has stood as a symbol of cosmic stability and reliability, a fixed point amidst the ever-shifting tableau of the cosmos. Yet, despite its apparent permanence, Polaris is not immune to the inexorable march of cosmic time. Like all stars, it is subject to the forces of stellar evolution, undergoing a series of transformative stages that ultimately shape its destiny. And now, as astronomers peer ever more deeply into the celestial fabric, they are beginning to discern signs of change, subtle fluctuations in the star's luminosity and behavior that hint at an impending cosmic upheaval. The origins of Polaris' impending fate lie in the intricate dynamics of its internal structure and the delicate balance of forces that govern its behavior. As a variable star, Polaris exhibits periodic variations in brightness, known as pulsations, which result from the interplay of gravitational forces within its core. These pulsations, while normally regular and predictable, have recently begun to display anomalous patterns, deviating from the expected norms and confounding the expectations of astronomers. At the heart of these anomalies lies a profound mystery, a mystery that has sparked intense speculation and debate within the astronomical community. What could be causing these irregularities in Polaris behavior? Could they be indicative of underlying changes within the star itself, or do they signal the onset of a more cataclysmic event, a cosmic explosion that could forever alter the face of the night sky? The possibility of a cosmic explosion, a phenomenon more commonly known as a supernova, has emerged as a leading hypothesis to explain the observed anomalies in Polaris behavior. In essence, a supernova represents the final, spectacular act in the life of a massive star, marking the culmination of its evolutionary journey and the release of titanic energies that reverberate across the cosmos. For Polaris, a supernova event would herald the end of an era, a cataclysmic finale that would transform this once steadfast beacon into a fleeting blaze of celestial glory. In the moments before its demise, Polaris would undergo a dramatic metamorphosis, its outer layers blasted into space in a brilliant display of light and energy. For a brief instant, it would shine with the brilliance of 1,000 suns, illuminating the heavens with a brilliance unmatched by any other celestial body. But beyond the spectacle of its demise lies a deeper question. What will become of Polaris in the aftermath of its cosmic explosion? Will it leave behind a remnant, a dense, compact core known as a neutron star, Or will it succumb to the inexorable pull of gravity, collapsing into a black hole from which no light can escape? The answers to these questions remain elusive, hidden within the labyrinthine corridors of theoretical astrophysics and observational astronomy. Regardless of its ultimate fate, the loss of Polaris would reverberate across the astronomical community, reshaping our understanding of the cosmos and challenging the very fabric of our celestial navigation. No longer would sailors and astronomers be able to rely on its guiding light to chart their course through the night sky. Instead, they would be forced to recalibrate their instruments and recalibrate their understanding of the heavens. Yet, amidst the uncertainty and speculation surrounding Polaris' fate, one thing remains clear. The cosmic drama unfolding in the celestial realms serves as a poignant reminder of the impermanence of the cosmos and the ever-changing nature of the universe. As we gaze upon the night sky, we are reminded of our own place within the vast tapestry of creation, a tiny speck of dust adrift in an ocean of stars. In the end, the story of Polaris is not just a tale of celestial evolution and cosmic catastrophe. It is a testament to the enduring quest of humanity to understand the mysteries of the cosmos and unlock the secrets of the universe. And as we continue to probe the depths of space and time, we are reminded of the boundless potential of human curiosity and the infinite wonders that await us among the stars.